So here we're going to solve a combo circuit, and a combo circuit is made up of both series. This part here is in series, and then we branch here into a parallel. So when we're doing these, we have to, first of all, we want to find the equivalent resistance, and we call that Req. And so that will be the resistance here, which is 2 ohms, plus the resistance of this area here, this parallel area right here. And so this will be 1 over 2 plus 1 over 4. So if you do this math, the total or the equivalent resistance of the whole thing is 2 ohms plus 1.3 repeating ohms. And so your total resistance is going to be 3.33 ohms. And that's repeating, but 3.3 is probably fine to blow it out to. So we make our table VI and R, where we have resistor 1, resistor 2, resistor 3, and then we have the total. And then we fill in from there. And I hope I give myself enough space here. So the total here is 10 volts. And here I have 2 ohms. And here I have 2 ohms. And here I have 4 ohms. And the equivalent resistance, and I'm going to put a line right there to show you that that section is different. And here's the totals. So this is 3.33 ohms. And so if I want to do this one right here and solve the total current, I can do that right now. It's 10 divided by 3.33, and I get almost exactly 3. It's 3.003 amps. So in anywhere there's a series, the amps will be the same as the total. So this will also be 3, which means there's 3 amps flowing through this spot right here. There'll also be 3 amps flowing through this spot here, but a portion will go that way and another portion will go that way of the amps. And so some of the electrons will go that way and some electrons will go that way. So the amps actually will be divided up here. And this plus this will equal to 3. The volts, on the other hand, we can figure this one out real easily because this is going to be 2 times 3 is 6 volts. And that means that this section has to be 4. And since this is parallel in this section, since it's parallel, that if this one's 4, this one also must be 4. So 6 plus 4 equals 10. Now this area is going to be 6 because, this area, the total is going to be 3. So this plus this should equal 3. So what's 4 divided by 2 is 2. And what is 4 divided by 4 is 1. So this one will have 1 amp traveling through it. And this one will have 2 amps traveling through it. And 2 plus 1 is 3. Anyways, this is the total solution to the whole thing. The volts here and here are the same because it's parallel. So I have 4 volts on each side. And the volts here is easy. It's 2 times 3 is 6 volts. And then if I take this 4 volts and add it to the 6, then I get my total of 10. That and that. So the patterns still work out. It's harder to see because you have a series and a parallel circuit together, but they do still work out. The key is to be able to look at the equivalent resistance first, and there's several different ways to do this, and it can get more complicated than this, but this is the most basic version you're going to see it in. And go ahead and try that on the 7EC quiz. Voila.